Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to talk about problem solving with percents. Percents are one of those subjects, areas that are very important, used every single day in life. If you've ever purchased something, we're dealing with percents. If you ever paid tax on anything, you dealt with percents. If you ever tipped your waiter or waitress at a restaurant, you're dealing with percents. If you ever wanted to calculate your average in a class, you're dealing with percents. If you have money invested in the stock market and you wanted to find the percent change of your stock, you're dealing with percents. Percents have a multitude of uses and it's very, very, very powerful. So let's really understand it today. There are two ways to solve percents: a proportion way and an equation way. The proportion and the equation are exactly the same thing. It's just a matter of how you read it. Just so you understand, I didn't get good at proportion method till I was much older, okay? It wasn't until I was a teacher that I actually saw the beauty in the is over of and percent over 100, believe it or not. I kept doing the equation, but because of my equation skills are so awesome, I can turn it into a proportion really easily. So when we're looking at what percent of a whole is a part, we're looking at the proportion n over 100 equals is over of. So n is the percent, but without the percent sign. There is no percent sign. It's just the percent over 100 equals is over of. The is belongs to the part. That is the answer to the equation. And the of belongs to the whole. That is the main whole part of the equation. As far as in the equation form, not in a proportion form, I look at it like this. What percent? Well, what percent? X percent, because I don't know. Of means multiply. Whole times the whole. Is means equals. Part is P. So X percent, I could rewrite that as a decimal, or I could put X over 100 times W for the whole equals P for the part. You got to know how to toggle between both of these because it's going to make you that much more efficient and effective when it comes to working with percents. Okay? Make sense, guys? Okay. So, let us continue. There are three types that we're going to learn of percent problems where they can ask you for the percent, the whole, or the part. Then we're going to learn about markup, taxes, and discounts. Then we're going to learn about percent change. Okay, that's why I broke this up into two different parts today. But today we're going to learn how to find for the percent, the whole, and the part. I want to find the percent. So you'll have a question as such. What percent of 12 is 2.4? What percent of 12 is 2.4? If you know your proportion method, you've probably been working with that since you were in middle school. The percent is, you don't know it. So that's X or N, whatever you want to use, over 100. That's my percent. So N over 100 equals is, the is attached to 2.4, over of, which is 12. And then here you would literally cross multiply. 12x equals 240. Divide by 12. And x would equal 20. That is totally cool, awesome, and great. If you're like me, you don't see that very easily. So put it into an equation. What percent? X percent. I have no idea. Of times 12 is means equals 2.4. Divide by 12. X percent equals, it's going to be 1, 2. Wait, is that going to be 2? No, 0.2. But I want it in a percent, right? So X equals 1, 2 to the right, 20%. That should be a percent sign as well. Does that make sense, gentlemen? So it's just a matter of learning how to set it up the way that it works for you. The is over of and n over 100 is great. It's beautiful. But you got to understand how to work with it with the equation, because later they're going to get a little bit more complicated and you have to figure out the logic behind it. Okay? Next, finding the part. 32% of 8 is what number? Yes, sir? Okay, go ahead. 32. No, 32 over 100, right? Because it's 32 over 100 equals, no, is over of. So it's 32% of 8. They have the of 8 is what number? That's my x. So it's is over of. Okay. Or if you wanted to go the equation route, 32%, so that's 0.32 of times 8 is equals what number? X. Either way works with me. Yes, sir? Correct, but the variable x could be at the is, or it could be at the of, or it could be at the percent, depending on what they're looking for, sir. Okay, so that's 256 divided by 100. So x will equal 2.56. Or if you just multiplied here, 0.32 times 8, that gives you 2.56 equals x. So again, please note, you don't have to do them both ways, but you got to do them one way. So learn it. Yes, sir. How can you, no, because you're not, okay. The question was, can you simplify this x and 8? No. Because this is a cross multiplication, not a, this is an equation, it's a proportion, not a multiplication problem. If I had 32 over 100 times, whatever, x over 8, yeah, we could reduce the 32 and the 8. But you cannot do that with the proportions, sir. Good question. Thank you, my brother. Okay, next, finding the part. 20% of what number is 8 this time? Well, as far as proportion goes, we got percent over 100 equals is, which is 8 this time, over of, which is x, because we don't know the of. Or, if that just doesn't make sense, 20%, that's 0.2, times what number x is means equals 8. So either way, we could do this, okay? Here I'd cross multiply. 20x equals 800 divided by 20. X equals 40. Or I can divide by 0.2 and x will still equal 40. So that's how you find the part, the whole, or the percent. Yes, sir. Yes, you could simplify the 20 over 100 if you so chose. Yes, sir. 100%. Yes, sir. No, you cannot simplify across. Correct. You cannot simplify across here, but this side of the equation I can simplify. That could become 1/5. Thank you, my man. But you cannot cross reduce when you're dealing with a proportion. Thank you. Great question. Thank you, thank you, thank you. All right, now discounts and markups. Okay, this is where logic has to come into play, guys. When you have a discount, you are subtracting a certain percentage from the original amount. You are subtracting the discount from the original price. So what happens here? Yes, sir. Yes, sir. Let me teach you first before you give me hypotheticals, please. Thank you, my brother. Okay, because I may answer your question. You know what I mean? Thank you, my man. So for discounts, again, guys, you're subtracting. You're taking away. So there's two ways to figure this out. A shirt costs $38.50 is on sale for 30% off. Find the discount and sale price. Okay. I'm going to walk you through the old way of doing it, the way they teach it in middle school, and there's nothing wrong with this. There's nothing wrong with this, but it's going to lead you down a very confusing path when they get a little bit tougher. But the traditional way is, okay, you have something that costs $38.50. I want 30% off. So I can multiply this by 30%, and 38.5 times 0.3 is 11.55. This is what's called my discount. This is what you are subtracting from the original price. So in step 2, 30% of 38.50 is 11.55. So you take your 38.50 and you subtract your discount of 11.55. That's 5. That's going to be 9. And that's 26.95 is my final sale price. This is what you pay. Okay? That's all fine and dandy. I think it's a little bit basic. I think it's a little elementary. And I think that it's not going to get you where you want to go to when they get tougher. So what do? Think about this logically, okay? The 38.50, didn't that equal 100% of the value of that shirt? Okay. Am I not taking away 30% for a discount? So am I not really paying 70% of the original? Don't just say yes to me. Does that make sense? So let's redo this. I have a shirt that's $38.50, but I want to find the sale price after a 30% discount. So am I not really? So am I not really just taking $38.50 times 70%, which is 0.7? And when I get 38.50 times 0.7, that equals, in one step, $26.95, which is my sale price. Because you already found the new price after the discount. Now, if they told you, how much did you save, how would you find that? Subtract what? That's right, $38.50 minus $26.95, and that tells you what your discount was. But this is the way to think of percents, okay? You got to think of it this way. For example, this is where the first method is not going to render you any good stuff. You paid $45 for a shirt after a 25% off discount. So that's already what you paid for. That's what you paid for after the discount. Find the original price of the shirt. This is where your is over of and your proportion setup is not going to be very good unless you write the equation first. 90% of people will probably go, oh, 0.25 times 45, and now you add it back, right? Who would have thought to do that? Be honest. Be honest. Thank you. Now you're going to learn. You never do that. Think about your logic there. What you're saying is 25% of the $45 is the same as 25% of the original amount. That's wrong. You paid for what percent of the original amount here, guys? 75. Thank you. You paid 75% of the original. And 75% of the original equals $45. So it's 10 over 100 equals is over of, which is the original, which is what I'm looking for. Do you see that? Yes, sir. Yes. I'll do that in a second. Hold on. You messed me up here. Okay. And then divide by 75. And then x would equal 4,500 times, divided by, come on, modal, divided by 75, which would equal $60. Okay. Now you were saying, let me see. Oh, no. 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 Because what he asked was, can't I multiply the 45 by 125%? No. because then again, you're taking the 25% from 45. The 45 is your answer. That's it. That's your answer. So the only way to do this is 75% of what original number gave me the answer of 45. If you multiply 45 times 1.25, my brother, you get 5625. No, you cannot work with the answer. That's why knowing how to set up the equation is crucial for this. Does that make sense, gentlemen? Talk to me now, guys. Okay. Now, the good news, almost exactly the same. Markup. Markup is the exact opposite of discount. You're adding a certain percentage to an original amount. You're adding the markup to the original amount. So a shirt at a department, a shirt costs a department for $12. Okay. If the store applies a 300% markup on the shirt, how much do they sell it for? Okay. After the markup. The old way, okay, the way you learned in middle school, you would have gone, okay, 12 times 300% is 3, so that's $36. That's my markup. That is what they are adding to the cost to make money. So your final price would be $12 plus the 36 markup. So you pay $48. That's my selling price. It's not a sale price. A sale price is after a discount. This is the selling price. This is what they're going to charge you and me. Okay? That's one way to do it. Find the percent and then add it to the original. That's fine. But that's a little bit Mickey Mouse. Think about it percent-wise. They paid $12, right? $12 equals 100% of the cost. But they're adding a 300% markup. So in the end, aren't you really paying 400% of the original? Does that make sense? Yes, sir. Okay. Thank you, sir. $12 is the 100%, right? That's 100% of what I paid, right? But now I want to add a 300% markup. So I have my 100% that I paid plus the 300% that I'm marking it up. Am I not paying 400% of the original? So if I'm paying 400% of the original, 400% of original, which we don't know, equals $12. So that's percent over 100 equals is over of, cross multiply, and X will equal $48. Does this make sense, brothers? Great question. Thank you so much. Yes, sir, my brother. Thank you. It's 300 because it says the store applies a 300% markup. Thank you, sir. Any other questions on this, gentlemen, before we continue? Thank you, brothers. Okay, how about this guy? Now, I'm doing this on purpose to you. The bill at a restaurant was $56. Find the total amount you must pay after a 20% tip. Okay, so what do you do?
So from there, you just go back to multiply.
Okay, multiplying. How do you want to do it, my man? Okay, we could go that route. You go 56 times 0.2 because it's 20%, so it's 0.2. So we've got 1120. And that is my tip. Okay, that's what I add to the bill. So now my total bill will be 56 plus 1120. So that's $67.20. That's my total bill. Yes. What's another way to see this? Yes, sir. No. No, God, no. Yes, sir. No. 56 over X equals 20 over 100 will only get you the tip. It will not get you the total price. No. Guys, what is 100% of the total bill? Okay. Am I not adding 20% for tip, guys? So am I not paying 120% of the original? What aren't you seeing here? So it's 120 over 100 equals is over of. And the of is $56. Cross multiply, and x will equal $67.20. If I wanted to find my tip, then I could subtract that from the original. But this is the way you do it, guys. Please talk to me. Please talk to me. Yes, sir. No, he was doing it completely backwards because he was subtracting on a markup. And that's completely wrong. So no, please ignore what he was saying. That's a discount. You don't add, you don't subtract on markups. Yes, sir. I didn't say that the first way doesn't work. I never said that. Okay, this first way here, I never said it was harder either. I said it's more time consuming. Because you have to find the 20%, then you have to add it. Now, why is this not as useful? I think we're done, right? No, we got a few more here. I wanted to show you simple interest. Okay, look. Let's say I were to give you this. Your bill, your total bill after a 20% tip was, let's say it was, let's just make it easy, $120. Okay? I want to find the original bill or the original cost. How would I do that? Yes, sir. Thank you. You paid 100% of your bill plus you paid a 20% tip. So you paid 120% of what number, of what bill to give me a total of 120 that you spent? Yes, sir. Yeah, so X, I divide, actually, no, it's not going to be 100. This is 120 over 100 equals is over of. So this would be 120x. Wait, will it be 100? 1, 2. Yep, you're right. So x equals $100. Gentlemen, all of your homework is valid. Have a great day. Thank you very much. We'll talk later. Bye-bye. Hope you learned a lot.